Okay, let's see if we can have a look at this problem. Now, this circuit, the way it's been drawn, may not appear to be too familiar to you. So let's see if we can redraw this, and I think this will really help. So, all right, here we go. Here is the op-amp itself. Here is my non-inverting input. Now let's have a look at what's connected really to non-inverting input. This is the output voltage sitting here. Well, look, from the output to the non-inverting input, what do we have? We have a 20K resistor. So let's go ahead and put that guy in. There it is. That's my 20K resistor. All right, the other side here, this point right here, to ground in this case, or 0 volts, is a 4K resistor. So that also is connected, is it not, to the non-inverting input. So really what I've got here is actually a 4K resistor. This is going to be then my reference voltage, which is V reference. But in this case, that reference voltage is really held at 0, is it not? Then at the inverting input, like the previous discussion, we have our input voltage Vin. Once again, it's still a consideration of Vin being equal to this voltage here, which we're calling V1, to understand the switching consideration. Okay, so let's see what we can do here. First of all, let's write the equation down for V1. V1 is equal to, well, what is it equal to? Well, it's this 20K divided by the sum of the two, which is what, 24K, times that reference voltage, V reference, okay, plus 4K divided by the sum of the two, which is 24K, times what? The output voltage, V out. All right. In this case, we really know that to be what? It is actually a 0. So this term really disappears. And so we can really say then that V1 is simply equal to 4K divided by 24K times that output voltage, V out. Switching is going to occur then when this Vin becomes equal to that V1 term. Now let's look at a starting case. Let's look once again at this output starting off, let's say, at a plus 15. All right? So we're going to say switching occurs when basically Vin becomes equal to V1. Okay? Now that's going to be a specific value of Vin because we're going to switch what? From a high really to a low condition here. All right, so we're going to call this point here, we're going to call it VNL, going from a high to a low value, a minus 15 volt value. All right, so let's now go ahead and simply evaluate that VNL. So VNL is really equal to V1, which is 4K, over 24K, times V out. Well, our assumption was V out is a 15, okay? And so therefore, if I evaluate that term there, this comes out to be 2.5 volts. So this VNL is actually sitting at 2.5 volts. So as I increase Vin becomes equal to 2.5 volts, which is the V1 value, then this output's going to switch from a plus 15 to a minus 15. All right, now we have to consider the output switch to a minus 15. If I start to decrease Vin, when do we actually switch back to the output going to a plus 15? Once again, it's that same expression for really V1. V1 is equal to what? 4K over 24K times the output voltage, V out, okay? Now, switching occurs, same statement, switching occurs when Vin becomes equal to this V1 value. This time, of course, this V out is what? It's not a plus 15, it is a minus 15. So therefore, V in, specific value now, V in is going to go from what? A low to a high. So V in H is going to be equal to this 4K divided by 24K times my output voltage, which is now a minus 15. Okay, so evaluating this here, we find that V in H is actually a minus 2.5 volts. And so what we're really seeing is, starting from this position, as we decrease V in, we actually switch back to a high or a plus 15 V out, and this happens really at a value of V in being minus 2.5 volts. Okay, that is the solution to that particular problem. All right, I'll see you next time.